So like I mentioned in the last video, if you have a hard time writing numbers with significance, especially when there's zeros involved, scientific notation can help us with this. So what scientific notation is it's a way of writing really big or really small numbers, or even just any number, and recording significance. So what happens is that a number written in scientific notation will always have a number written here, which we call a coefficient. It'll always be a number between 1 and 9, meaning that you'll only ever have one number to the left of the decimal place, and then you'll carry however much significance you want. So for example, if you have 3 digits written here, that's 3 digits of significance. So if you have 2, it's 2. If you have 1, it's 1, and so on, which makes it really nice. And then you always put times 10 to the, and then you have an exponent on the 10, and it's either going to be positive or negative. It's positive for very large numbers because you're going to be multiplying by 10, and it's negative if it's really small numbers because you're going to be dividing by 10. So to write any number in scientific notation, what you do is you move the decimal place until your coefficient is a number between 1 and 9. In other words, you only have one digit to the left of the decimal place, and then you maintain sig figs however many you want, whether you're just maintaining significance of the number or whether you're rounding to a certain number of significance. And then you count the number of places you move the decimal. This is going to be your n value, so the exponent on the 10. If you move the decimal place to the right, in other words, you had a small number, your exponent will be negative, which means you divide by 10. And if you move the decimal place to the left, meaning it was a large number, your exponent will be positive, meaning that you're going to multiply by 10. So for example, I've chosen two numbers here. They just happen to be chemistry examples because they deal way more with really small and really big numbers than physics does. But something like Avogadro's number, which if I'm correct is the number of molecules in a mole of a substance. Okay, but what it is that this is a huge number. The decimal place is way down here on the end. In fact, there is no decimal place. So this number would have 3 sig figs. So what we're going to do is we're going to move this decimal place all the way to in front of the 6 because we only want one number to the left of the decimal place. And then we are going to count how many places we moved it. So we have 3 sig figs. So we have that 602. But we're going to move the decimal place. 3, 6, 9, 12, 15, 18, 21, 22, 23 places. So we put times 10 to the 23. Then we look at an electron's mass. So for again, let's count the significance. This one has 2 digits of significance, so it's 9.1 is what we want. If there had been 9.10, right, we would have put a 0 on the end of it. And then we just move the decimal place. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 28 places. But this time we moved it to the right, which means we had a really small number, so we put negative 28. This means we have 9.1 being divided, because a negative exponent means division instead of multiplication, divided by 10 28 times. Whereas this one, we have 6.02 timesing by 10 23 times. All right, so what we're going to do first is we're going to just practice maintaining significant figures and writing numbers in scientific notation. So here's my first one. Okay, when I look at this, this is just a negative number, so I just write the negative out front. And then my significant figures, there's 3 significant figures, 3 sig figs. So we're going to write 1.07. I always do that first. I know where my decimal is going to go. So when I have 3 significant figures, I write them down, and I always make sure the decimal place is after the first number. Then where is my decimal place? Well, my decimal place is down here at the end, but it's not there, so these zeros were not significant. And I'm moving it 1, 2, 3, 4 places. So I'm going to put times 10 to the positive 4, right? Which means if I took this number and I multiplied it by 10 4 times, I would get 10,700. This one, how many sig figs does this one have? This one has 4 sig figs. So again, I'm going to take those significant figures, 6.025 times 10 to the, and then I figure out how many places I move my decimal place. So it is here, and I go 1, 2, 3, 4, 5, 6 places. So it's times 10 to the negative 6, because if I now take this and I divide by 10 6 times, I'll get this digit up here. All right, pause the video and give these two a go. Okay, so this one has 4 sig figs. So I'm going to write 1.806 times 10 to the 1, 2, 3, All right, this one has 3 digits of significance, so it's going to be 6.70, and again, that negative can just come out front. Times 10 to the, I'm moving the place 1, 2, 3, so times 10 to the negative 3. This one had 3 sig figs. All right. Now just making sure that you can go backwards. So here's 2 numbers that are written in standard form, or written as scientific notation, and can you go back to standard form? So what I'm checking for is, do you know how to write this as a really small number or a really big number? You know, which one's which. So for this one, because it's times 10 to the negative 5, I'm going to move my decimal place to the left, 1, 2, 3, 4, 5. So I moved it once, and then I have to fill in 4 zeros. So I'm going to put 0.0000286 right? So the 2860 has to be there, and then I had to put 4 zeros in front, and then I put this 0 as a placeholder. For this one, it's times 10 to the 6, so this is making it a bigger number. So I'm going to multiply it by 10 2 times, and then I need 4 more zeros. Awesome. Now what we're going to do is the whole shebang. So we are going to write these numbers in scientific notation with a specified number of significant figures. Now, you're more than welcome to round them first and then write them in scientific notation, or you can do both at the same time. So for example, this one, I want to write this one with 2 significant figures. So I'm going to take the 98 and I'm going to round the 8 to a 9. So I'm going to put this as 9.9 times 10 to the. Now I'm moving the decimal place 1, 2, 3, 4. So it's going to be times 10 to the negative 4. And again, if that was too many steps at once, do the first step of rounding, then write as scientific notation. Totally up to you. Okay, feel free to pause the video and give the other ones a go if you think you've got it. So for this one, I'm going to write this as 3 sig figs. So I'm going to put the 4, 5, 6. The 6 is going to round because of the 8. So I'm going to first off write this as 4, 5, 7, 0, 0, 0, 0, if you like that. Personally, I don't know. I feel like that's almost a bad step for me because then you have to know about the zeros. Instead, I would say 3 sig figs. Okay, 4.57 times 10 to the, there's decimals here, I go 3, 6. And hopefully that makes sense. Okay, 2 more. So for this one, 3 sig figs, I'm going to write this as 810. So I'm going to put the decimal there, and I'm going to put times 10 to the 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Yeah. All of a sudden I was doubting myself there. Okay, and then this one with 1 sig fig, I only want the 3 because it's a 4 beside it. I keep it as a 3, and then I just do 3 times 10 to the 3, 6, 7, and it's going to be a negative 7 because it's a small number. All right, hopefully that made sense to you, and that is the end of our introduction to counting significant figures.